Carbon dating, an application of exponential decay. All living matter contains traces of radioactive carbon-14. When an organism dies, the carbon-14 decays with a half-life of about 5760 years. Therefore, the age of an ancient specimen can be determined by measuring the radioactivity of carbon-14 it contains and comparing it with that of living matter. Determine the approximate age of specimen with about 24% radioactivity of carbon-14. Now, carbon dating examples, we have 3 in this sequence, and I'd like you to go through those. So let's begin with the formula, which is the percent of carbon-14 remaining is equal to initial amount times half-life. Half-life is T over H, so T, and half-life is given to us as 5760. Okay, 5760. Now, in this particular case, we are given 24%. That means if you start with 100, we are given 24 is the remaining, right? So that is what it means when we say 24% radioactivity of carbon-14, correct? Now, if we substitute those values, then we can find the value of T, right? So we can have here 24 is remaining if we start with 100. So that is what it means. 0.5 I'm writing instead of half to the power of T over 5760. Now from this, there is only one variable, and that is time, which we can calculate. Now there are 2 ways to calculate it. One, of course, is you can estimate. Substitute different values of T and then try to get your answer. The other one is to use log, right? So taking log is a better way of doing it. Well, those of you who have not yet applied the method, let me tell you here, we can take log on both sides. So if you do that, you get, first we can write this as 24 divided by 100. So what do we get is 0.24 equals to 0.5 to the power of T over 5760. Now let's take log on both sides. So if you take log on both sides, you get log of 0.24 equals to, when you take log, the exponent comes as a product like T over 5760 and log of the base, which is 0.5. You can consult some books and then understand this method, but that is how it should be done. Now from here you can find what T is, right? So T will be ratio of log of 0.24 divided by log of 0.5 times 5760. So let me write down T as equals to 5760 times log of 0.24 divided by log of 0.5. Now you can use calculator and find time. So it is 5760 times log of 0.24 divided by log of 0.5, which gives you 11,859. So 11,859 years. So that is the age of the specimen, right? So you can say around 12,000 years. Right? So about, you can say 11,900 years, right? So it gives an approximate value, and from here you can say it is that old, around 11,900 years.